Assalamualaikum and a very good day everyone. We are the students from Bachelor of Computer Science, Computer Network Security, University Sultan Zainal Abidin, and today we are going to discuss on our project titled Memory Management. So before we going into deeper, let me first introduce our team members. Our team members consist of Luqman Hakim, Cikgu Nur Syakirul Aiman, Muhammad Faris Haikal, which is myself, Muhammad Nabil Hafiz, and Muhammad Waldan. So let me go to the first chapter, which is Introduction to the Memory Management. So what is memory management? Memory management is the process of controlling and coordinating computer memory by allocating bits of memory known as block to numerous running programs to maximize overall performance of the system. Memory management is managed by hardware, the operating system, and the application software. The Von-Neumann stop program principle is the fundamental operating principle of digital computers. First and foremost, we must store all information in some form of storage, most known as main memory, and the CPU only interact with the main memory. As a result, memory management is an important consideration when designing a computer system. On the other hand, everything cannot be implemented in hardware because the system cost would be prohibitively high. In hardware, memory management consists of the components that physically store information such as RAM chips, memory cards, and flash-based SSDs. Memory management is the operating system entails allocating and constantly reallocating specific memory blocks to individual programs as a user's demand change. Memory management at the application layers ensure that enough memory is always available for the objects and data structure of each running program. Allocation and recycling are two related tasks in the application of memory management. I guess that's all from me from the chapter 1. So I would like to invite my friend Luqman Hakim for the next chapter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Luqman Hakim. I'm going to go into the next chapter, which is the characteristic of memory management. The memory in a computer can be divided into 5 hierarchies based on the speed as well as use. The processor can move from one level to another based on its requirement. The 5 hierarchies in the memory are registers, cache, main memory, magnetic disk, and magnetic tapes. The first 3 hierarchies are volatile memories, which means when there is no power, and then automatically they lose their stored data. Whereas the last 2 hierarchies are not volatile, which means they store the data permanently. A memory element is the set of storage devices which store the binary data in type of bits. In general, the storage of memory can be classified into 2 categories such as volatile and non-volatile. The memory hierarchy design in a computer system mainly includes different storage devices. Most of the computers were inbuilt with extra storage to run more powerfully beyond the main memory capacity. Refer to the hierarchy, there are 8 characteristics of memory management. The first characteristic is location. It deals with the location of the memory device in the computer system. There are 3 possible locations, that is CPU, internal or external storage. Next is capacity. The capacity of any memory device is expressed in terms of word size and number of words. Word size are expressed in bytes. A word can, however, mean any number of bytes. Commonly used word size are 1 byte, 2 bytes, and 4 bytes. Number of words is the specific number of words available in the particular memory device. The third characteristic is unit of transfer. It is the maximum number of bits that can be read or written into the memory at a time. In case of main memory, it is mostly equal to word size. In case of the external memory, unit of transfer is not limited to the word size. It is often larger and is referred to as block. The fourth characteristic is access method. It is a fundamental characteristic of a memory device. It is the sequence or order in which memory can be accessed. There are three types of access method, which is random access, serial access, and semi-random access. The next characteristic is performance. It can be determined using three parameters, which is access time, memory cycle time, and transfer rate. The next characteristic is physical type. Physical unit physical type. Physical type can be semiconductor memory or magnetic surface memory. The second last characteristic is physical characteristic, which is either volatile or non-volatile. The last characteristic is organization, which mean memory can be erasable or non-erasable. Okay, that's all from me. I would like to invite Muhammad Waldan to continue with the next chapter.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today I will share with you about the advantage of memory management. First of all, these are the advantages of memory management. First, there is no fragmentation in internal memory. The process of having a code segment, data management, and many more segments for storage when it loaded into memory or a system, allocated variable line segment to each, such as data and code. So, no internal fragmentation for memory management. Then, if segments are small, it may be saved into its memory and it should not be job management technique in which each job is divided into several segments of different size, one of each module that contains pieces that perform related functions. So, if the data is bigger than a segment, the memory management will backup a segment by save the data into a memory. Next is memory management have less overhead. Overhead memory depends on the number of virtual CPUs and the configured memory for the guest operating system. Overhead memory allocated on virtual machines. Simple to explain, that is the cost or power needed to running the app's user is low and doesn't need a power while the user use the memory. Then, memory management also manage the computer's primary memory. It is the most important function of an operating system that manage primary memory. It helps process to move back and forward between the main memory and execution disk. It helps OS to keep track of every memory location, irrespective of whether it is allocated to some process or it remains free. The memory management functions keeps track of the status of each memory location, whether it is allocated or free. It determines how to allocate memory among competing processes by deciding which process will get memory, when they will receive it, and how much they are allowed. It tracks when memory is free or unallocated and updates the status. Without proper memory management, the computer doesn't know where it is in processing a function. It is immediately lost and the programs will crash. Memory management also keeps track of each and every memory location, regardless of either it is allocated to some process or it is free. It checks how much memory is to be allocated to process. It decides which process will get memory at what time. It tracks whenever some memory gets free or unallocated and correspondingly, it updates the status. Memory management refers to the OS function responsible for managing the computer's primary memory. So that's all from me. I would like to invite Muhammad Nabil for the next part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So I will talk about disadvantage in the memory management. The first disadvantage in the memory management is availability of external fragmentation. External fragmentation occurs when allocated memory blocks are of varying size. Internal fragmentation occurs when a process needs more space than the size of allocated memory block or use less space. External fragmentation occurs when a process is removed from the main memory. Second, algorithms of the memory are costly. Each involves a bunch of tasks or problems to solve and has effect on CPU states. Tasks include keeping track of the state of allocated memory block, a bit of search for a suitable free block to allocate, and zero file operation. After that, uh, paging keep running of free page. Paging in the memory management allow the cumulative total of virtual address space to exceed physical main memory. A process can store data in memory map files on memory backup file system, such as the temporary file storage or file system on a RAM drive, and map file into and out of the address space as needed. And the lastly is segment is inconsistent size not fit also for trading. Segmentation is a memory management technique in which each job is divided into several segments of different size. On one for each module that contain pieces that perform related function. Each segment is actually a different logical address space of the program. Since there is a variably sized partition, so it is difficult to allocate memory to them. That's all from my chapter. I would like to invite my friend Cik Nur Shakirul to present the next chapter. Thank you.
Okay, Assalamualaikum. For my chapter, which is conclusion. In conclusion, therefore, it is clear that memory management is one of the operating system most important roles. The operating system separate memory into primary and secondary memory to ensure that policies are in place to manage control various memory type properly. Primary memory is typically violated since it stores data and programs required for a process to run CPU, whereas secondary memory stores long-term data and programs. The operating system delegates memory management to the Memory Management Unit, which is the MMU, also known as the Memory Manager, in order to efficiently handle program and data in the primary memory. The MMU is located in the kernel of operating system. Process must be shifted in out of memory when application want to run in the CPU. The first fit policy and the best fit policy are two examples. In the first fit policy, the operating system assigns the process the first available hole, as long as it can accommodate the process. That's all for me. Thank you.